Welcome back. In this video, we're going to continue our discussion of topic models to discuss how to visualize them with Python. Now, I do want to very quickly return to the script we were working on in the last video to talk about saving this information. Now, we discussed when we created our topic model in Gensim using this wrapper for the LDA model, we added this prefix, which does let us save the output of the model into mallet-generated files. But we can also use Gensim itself to save the model so we can reconstitute it and then use it from within Python. To do this, it's relatively simple. We can simply say LDA model.save, and then we'll give it a file name. Here I've given it the file extension P because it does save it as a pickle file, which is an object serialization library in Python. I should warn you that if you do use pickle to save information, you shouldn't open any pickle file that you don't already know the contents of, because it is possible to put arbitrary code inside it. It's fine if we're creating it ourselves, so there are no worries here. If we have done that when we run our topic model, we can actually reconstitute the model itself using this line of code here, Gensim utils save load topic model.p, or whatever file name you gave it. In doing so, in a later script, you wouldn't actually need to completely rerun the model, because if you remember, running these models does take about, well, for this, about 30 seconds, but a much larger corpus might take minutes, hours, possibly even days if it's a large enough corpus. Then, in a different file, you could run the rest of this code from 55 down in another file. Now, you will note that I've also changed my mallet path here just to avoid using that ridiculousness with os.path.join, because that wasn't really the best way to approach it. Notice, of course, I have two backslashes because file paths in Windows use backslashes, but a backslash is also an escape character in Python, so you actually have to double them up. Okay? So let's get on to visualizing these topic models. So what I'll do is I'm just going to create another file here, and I'm going to call it something like tm_vis.py. Now we're going to be using matplotlib to visualize these topic models. This is a little bit out of date, and the style will look a little bit early 2000s, but for the moment, I just want to show you how to do this. So the first thing we'll do is we'll add our docstring. This script visualizes the output of our topic model. And I'll simply import matplotlib.pyplot as plt, which is your standard way of importing the pyplot module from matplotlib. So we have a few options for how we might want to proceed from here. We could load this information in from the Gensim topic model object by using that save load function. But in fact, what I want to do is I just want to work with the files that Mallet outputted, because it's good practice to kind of think about how data gets formatted in certain outputs and how we can rearrange it to visualize it. Okay? So there are a few ways I can visualize the output of my topic model. I can look at the topic distribution across the corpus. I can look at the topic distribution within each document, or I could look at the topic distribution across all of my documents. I might even want to look at the word distribution in any given topic. For this video, I'll show you how to look at the distribution of topics across the corpus and across documents. I'll leave it to you as an exercise to figure out how to visualize the words across a single topic. So let's get started. Let's look at where Mallet has saved the topic information. If I look inside the folder that contains this information, which is just this topic modeling folder, we can see that when I ran this federalist topic modeling, it added this fed prefix to all of my files. And here is where the information is. I can look inside the corpus file, which contains information about the corpus. I can look at the document topic distribution, which we'll look at in a minute, or I can take a look at this fed topic keys file to see how it's formatted. And if we look at it, what we can see is each line has the topic number, it has the topic weight, and it has the words in the topic. So this is actually a tab-separated file, and I can load this into my script to visualize this quite easily. So why don't we do that? I'll go back over here to my visualization script, And there are lots of libraries in Python that can load in structured data files, but I kind of like to do it manually just because I find that it's always good to be thinking about the format of the files that I'm working with. So I can do this pretty simply, and I'm going to use a context manager to open this. So with open fed topic keys.text as rf, and I'm just going to say topic info equals rf.read, and I'll go ahead and split it into individual lines. So that way this will create a list in which each item in this list is a line from that input file. Now, I might want to clean this up slightly because if you look at this file, if you scroll down all the way to the bottom, you can see there's an empty line here, which means that this will show up in my list as an empty string, and I kind of want to get rid of this. So the easiest way to do this is simply say topic info and then use a list comprehension. And I'll just say item for item in topic info if item is not an empty string. So from here, I can go through each item in this topic info list and I can extract the topic information. So it's always a good idea to create an empty object that will save this information for me. So here I'm just going to say topics, and this will be an empty dictionary. And this is where I'm going to put the information about each of my topics. So now I'm just going to iterate through each item in this topic info list. So for line in topic info, I'll just say the data equals line split tab character, right? Because each item in this line is split with a tab. So now I can say, topic number is, I'll just say topic num equals data 0 because that's the first item here. Then get topic weight, which is topic weight equals data 1, and get the words in the topic. Now, we're not actually going to do anything with these, but often it's good practice just to keep track of all your information. So here, I'll say topic words equal data 2, and here we need to split this on the space because each of these words is separated by a space. If we were really concerned about memory usage, we probably wouldn't do this, but this is a pretty small corpus, so we don't really need to worry too much about. So the next thing I want to do is save the information to the topics dictionary. Just move this slightly. Okay, and so now all I need to do is I just need to say topics, topic num equal, and then I'll set this to a list that contains the topic weight and the topic words. Now I can test to see if this has worked properly simply by printing topics, and I'll give it the first topic. Now notice that this is a string and not an integer because I have read it in from the file. And so now I'll save that, and I'll say python tmvis.py. And now we can see that this looks great. It has the topic weight, and it has all of the words. Now, I might want to make sure that this topic weight is treated as a floating point number. So here I can simply change it into a float. If I wanted to, I could also change these topic numbers into integers simply by saying int, just like this. But I will leave them as strings. Okay, so I don't need this print statement anymore. So let's visualize all this information as a bar chart. To do this with matplotlib, I'm going to need an extra piece of information. I'm going to need an index for this bar chart. And this is really simple to create. It just needs to be a list of integers from 0 to however many bars I have in my chart. I for I in range. Here, this is going to be the length of topics, because that will just check the length of the keys associated with this dictionary. And so now we need the weights. So get the weight of each topic. I'll say weights here is simply topics, string, string I, and this is the first object here, 0, for I in range, length, topic, and create labels for each bar. I'll say labels equals f topic I plus 1. So that way it's 1 to 40. For I in range, length, topics. So now all we need to do is visualize the results. plt.bar, we'll give it the index, and we'll give it the weights. Now we can also add some labels. So here we'll say plot.xticks. I'll give it index, and we'll give it labels, and maybe make the rotation equal 90. And we should also add an X label, which will be topic. We'll add a Y label, which will be weight. I'll add a title. I'll call corpus topic weights. And then I will go ahead and give it a tight layout just to make sure things are laid out fairly well. And then I'll do plot show. So ideally, if I run this, this gives us our topic distributions. So we can actually see that topic 18 is far and away the most common topic in this particular corpus. And so here, if we look at this, this is topic 17. We can take a look at it. Essential, objection, things, person, require, and so on and so forth. So we can see that this must be a pretty important topic across all of these Federalist papers. So that's visualizing one of these pieces of information. But what if we wanted to visualize the topic weights by document? Let's take a look at the doc topics file. So here we can see that the format is slightly different. Here we have the document number, and then we have the weights for each topic in that document. And in fact, it gives us the document number twice. And this will have 40 different weights. So each of these columns represents the weight of a particular topic in a particular document. So this formatting is slightly different than what we were just working with, so we do have to rearrange things a little bit. So for this next step, I'll go ahead and create another file that I'll call TMVIS2.py, and we'll get started. So here we're just going to visualize the topic weights within a given document. And here I'm going to import matplotlib .pyplot as PLT. And I'm also going to import OS because I'm going to go ahead and go back into my corpus folder and grab the titles of all of those files. So here what I can do is I can, create a set of ignore files. We've seen this in previous examples when we were actually creating our topic model. I'll say ignore equals a set with ds store and .txt. So the next thing I need is a list for the labels. So I'll just say titles equals an empty list. And then I'll just say for root there's files in OS walk fed papers. And then I'll just append the titles to this titles list. So I'll say for file name in files, titles append file name. And I'm going to go ahead and get rid of the file extension. And this should, of course, be file name. So here I can print titles 0. So if we run this, python tmviz2.py, we can see that the first item in this list is the 10th Federalist paper by Madison. So it looks like it's working. So I'll get rid of this print statement. And now we need to load in the data we're actually going to work with. We'll follow a similar procedure to what we just did when we were visualizing the topics across the whole corpus. Here I'll simply say with open fed_doctopics.txt. Again, reading it with a UTF-8 encoding as RF, and here we'll say topic info again equals RF split across the new line characters. We could use split lines, but that maintains that new line character in them, and I don't really like that. And we could do a similar thing to the last file where we get rid of that last line that is empty. Item for item in topic info if item is not an empty string. So once again, we'll say doc topic info, and this is going to equal an empty dictionary. So now what we want to do is we actually want to iterate through every item in topic info along with all of the titles at the same time, so we can save this information into doc topic info. So the next step is to iterate through the titles and the topic information at the same time. So we'll use zip to do this. So here I'll say for title line in zip, titles, and topic info. So this just lets us go through both of the lists at the same time. Now I'll say info equals line split on that tab character because it is a tab separated file. And now I'll save this information according to the title. So I'll simply say doc topic info title equals info. But in fact, I don't need the first two items in this list. If we look at doc topics and I go back to over here, we can actually see that this is just the topic number as it was loaded in. So what I can do is I can simply say for 2. So I can simply get everything after those first two items. But these also need to be floating point numbers. So I'll go ahead and do that with a list comprehension. So I'll put this inside of a list. I'll say float weight for weight in info to on. Okay? So this actually gets me most of the way to where I can start to visualize this information. So let's do that. Let's get out a weight of one of the documents that we want to look at. So I'll say weights equals doc topic info. And then I'll say, well, why don't we look at this 10 Madison? Because we already know that it's there. Then I simply want to get an index. So I'll say index equals I for I in range, the length of that weights list, because we'll have one bar for each topic. And now I can say plt.bar index weights. And again, let's make sure everything is labeled properly. I'll say plot.xlabel. This is topic. Plot.ylabel is weight. And plot.title is, well, it's 10 Madison. But I actually might want to change this. So why don't I go up to the top here, and I'll simply say doc to viz equals 10 underscore Madison. And then I'll take this here, I'll copy it down. I will give that to my title here, and I'll give it to this list here, just like this. And now I'll say type layout and show. So if I run this, aha, we can see that I made a mistake on line 22, and this should be rf.read.split. And now we can see that there are certain topics that are extremely important in this document, but others that are much less so. It's actually hard to tell which topics are which, so why don't we go ahead and add some labels really quick. So we'll say labels equal F, we'll say topic, again, I plus 1, for I in range, length, weights. And then we'll say plot.xticks, index, labels, and rotation equals 90. So now If we rerun this, we can see that this is much clearer. So we can see topics 3, 7, 18, 26, 35, and 36 are important. Now, I should point out that a lot of these numbers here are just extremely low. It's not like they don't exist. Because, for example, we can see that this first topic in document 1 is 1.9 times 10 to the e to the negative 5. So that's a very small number. We can see that topic number 3 is 0.57. So this is much higher. Here would be a place where an interactive visualization where you could zoom in would actually be pretty useful. So I can actually change this quite easily by looking at one of my different documents. So I could, for example, go into Federalist Papers and say, well, what about 1 Hamilton? So we'll say 1 underscore Hamilton. I'll close this. I'll run this. And now we can see 1 Hamilton, the dominant topics in that. So here we can see 13, 16, 18, 35, and 36 are important. All right? So that's already pretty useful. The last thing I'll show you in this video is how to visualize every document's topic distribution at the same time. This will be fairly similar to that signs at 40 visualization, where we looked at the shifting proportion of topics across all 40 years of the journal. Now, here we're looking at Federalist Papers and not information across time, so it's not going to translate perfectly, but if you are working, say, with newspaper articles, it would. So let's look at that really quickly. I'm going to go ahead and save this as TMVIS 3 because a lot of this code we're just going to reuse. So I will save as TMVIS 3. So here what I'll go ahead and do is I'm going to go ahead and get rid of all of this. Some of it will come back, but it's fine. So what we might want to do is we might want to visualize the weight of every topic in the corpus in each document. And to do this, we can create a stack plot that looks very similar to the signs at 40 stack plot. But in order to do this, we need to do a little bit of data munging, a little bit of data rearranging. You can use libraries like Python to make this a little bit easier, but we're going to do this in pure Python. So here, again, in this new TMVIS3 script, we're just going to make a couple of adjustments here. First, we need to make sure that we're keeping track of the total number of topics, which of course we know here is 40, but if we want to make sure this remains fairly universal, I'm just going to say total topics is 0. And here I'll simply grab the number of topics by checking the length of info 2 to the end. And I'm going to set total topics equal to this. Now, this isn't the most efficient thing in the world because, of course, we're grabbing it for each time through this loop. But because this is such a fast operation, it's not that critical. So this stack plot requires the data in a kind of strange format. Essentially, what it will want is a list of lists in which each item in that list is all of the topic weights per document. So here I'm going to create an object that I'm going to call doc weight per topic. And this is simply going to be an empty list for each one of my topics. So I'll say for underscore in range of total topics. And here this underscore just represents that I'm not actually doing anything with this information. So now what I want to do is I want to go through each of my documents and extract this information and put it into what is currently these empty lists. So here I'll say for title, in titles, I'll grab the weights, which should just be doc topic info title. And now I'm going to stick each of these weights into this list of lists. So here I'm going to say for I weight in enumerate weights, go ahead and say doc weight per topic index I. So that is I is the current topic number, and I'm going to append the current weight. And now I have the information reformatted in a way that I can make this stack plot. So I'm going to grab some indexes, and because my x-axis is all of the documents in my corpus, I'm going to say this should just be the range of the length of doc topic info. I'm going to grab some labels for each of my topics to make a legend. So here I'll say the labels are going to equal t colon, and then here I'll say I plus 1 for I in range total topics. And now I can make my stack plot. Here I'll give it the index, I'll give it doc weight per topic, and the labels. Labels equals labels. I'll go ahead and give it some xtick information, and here these should be the index and the titles, and I'll say rotation equals 90. I'll add a legend. This isn't going to look good because we do have 40 topics here, and also the colors aren't going to look good because we have too many topics, but that's fine. I'll give it a tight layout. And finally, I'll plot it. And so now I simply say TMVIS3.py. Of course, I still need to say plot show. And now I'll run it. And now we can see that we have our plot. And of course, we have too many topics. The legend doesn't look very good. And of course, it's very hard to tell exactly what's going on. But this is essentially the information that we were looking for. What I would suggest here is to spend a little time kind of exploring this, zooming in and looking at the different topics, and then thinking of a way to maybe clean this up a little bit. Maybe we have too many topics here. Maybe this would work better as an interactive visualization, and in fact, it definitely would. But this is the process to create something like this. We might actually adjust this into a stacked bar chart to make this a little bit clearer to see. And I'll show you how to do that really quickly. So I'm going to save this as TMVIS4.py, and then let's adjust a couple things. The first thing I need to do is I need to make sure I'm importing NumPy, import NumPy as MP, because this is going to make this much simpler. Here, the next thing I want to do is I want to change the way I am creating this plot. Basically, because there is no stacked bar chart functionality in matplotlib, I need to calculate the baseline for each slice in my bar chart. I can do this in a relatively straightforward way. I'm going to go ahead and get rid of all of this. And here I'll say calculate the baselines for a stacked bar chart. I'm going to say baselines equals a bunch of NP zeros, length of titles. So this is just going to give me an array of zeros, the length of my title documents. And I'm going to make sure this is baselines. And I'll make another cumulative list. And again, this is just going to be np.zeros, length of titles. And this is not a list of arrays, it's just simply an array. So now I'm going to go through all of the weights in the doc weight per topic list. I'm going to add them to cumulative plus or equals np.asArray weights. So this simply turns this list into an array, and then it lets me stack things on top of each other very, very quickly. So it'll just add these two arrays together based on the index. So the two items at index 0 in both of these arrays get added together. Items at index 1 get added together, and so on all the way through the array. This is something that's known as array broadcasting, and it's very, very fast. Now what I'll do is I'll take that baselines list of arrays, and I'm going to go ahead and append a list representation of these cumulative values to it. So essentially, it starts where everything is at 0, and then the first set of topic information gets added to it, and it keeps getting stacked all the way through. And now I can zip my way through all of this information to create my stacked bar chart. So here, for, I'll say doc weights, baseline, label, in zip, doc weight per topic, baselines, and labels, plot.bar, we'll give it the index, we'll give it the doc weights, we'll say the bottom equals baseline, and label equals label. And now we can go ahead and re-add all of our labeling information. So our xticks, we'll give it a legend, and then we'll show it. And now we can see that instead of that stack plot, we have a stacked bar chart where it's now a bar chart representation. And maybe slightly easier to read, but maybe not, depending on your opinion. Again, this is something that would be much easier to do as an interactive visualization because there's just too much information going on in this plot. But by that same measure, we now have at least the skills to visualize this information. So here, this is actually basically containing the same information that all of these individual little plots had when I was doing it one document at a time. So there you go. Now you know how to visualize topic models using matplotlib, and the principles are pretty much the same even if you change the library you work with. If you use something like Plotly, which will make it much easier to create an interactive visualization, that's also a really good option. So with that, that's what I wanted to talk about topic modelings. Good luck and enjoy your analysis. Thank you.